Welcome to EDU World Space.
Problem 3.120. In this problem, we have to calculate equivalent force system at point A. So in this problem, there are two pulleys B and C, and build on the pulley B has a 2 tension value on its side, and on pulley C the builds have tensions 145 and 200 Newton as indicated in this diagram. So first of all, to calculate equivalent force system, we will reduce this system into an equivalent force couple system at individual pulley center. What I mean to say that we will replace these two forces by an equivalent force couple system at point B, and we will replace these two forces that is acting on the pulley C by an equivalent force couple system at point C. And so we can convert this system. Let's say this was the point B, this was the point C. Okay, this was, let's say, point D, and this was point C. So we have to replace two forces, one force acting here, and that force will be equivalent to these two forces, and a equivalent force at C by replacing a single force because of these two forces, and corresponding moments because of those equivalence. So if we calculate the forces, that equivalent force that will act at point B, so we can write as force at point B will be, since this 250 Newton is acting in a minus J cap, so we can write it as minus 215 J cap, and this 145 Newton will have a component in J cap and K cap. So J cap component will be minus 145 cos 20 J cap plus 145 sin 20 K cap. So this comes out to be 49.593 Newton I cap minus 351.255 Newton J cap. So this was the equivalent force at point B. Now calculating the equivalent moment at point B, since we have calculated the equivalent force because of these two, so they are going to cause a couple also at point B. So the equivalent couple can be calculated by considering the direction by right hand thumb rule. We can get that this 145 Newton force is going to cause a couple about point B in positive I cap, so in plus x direction. So we can write it as 145 multiplied by radius, since this pulley has a diameter given in the problem as 150 mm, so its radius will be 75 mm, and to convert in meter we can write it as 0.75, and this moment because of this 145 Newton about point B will be along I cap, positive I cap, so plus I cap, minus, if we talk about the moment because of this 250 Newton, this will be along negative x-axis, so minus 215 multiplied by the radius, that is 0. It is 0.075 it will be, so we can correct it as 0.075. so this I cap, and this will be, unit will be Newton meter. So moment about point B, equivalent moment about point B comes out to be minus 5.25 Newton meter I cap. Now the similar procedure can be carried out for the point C. So if we talk about the equivalent force that is acting at point C, that will be this 155 and this 240 Newton, both are parallel to each other. So we can do two things, either resolve each of them individually, or we can do one thing, that equivalent force will be parallel to these two forces. So but it's better to directly resolve individually individual forces into its component along z-axis and y-axis. So if we write the moment, if we write the force component along j cap and k cap, so first component will be 155 . 155 cos 10 minus k cap and 155 cos 10 minus k cap plus 240 cos 10 again minus k cap and plus 155 sin 10 minus j cap plus 240 sin 10 minus j cap. So we can calculate these values. So RC comes out to be minus 389 Newton k cap minus 68.59 Newton j cap. So this is the equivalent force at point C because of these two forces acting on the pulley C. Now if we talk about the moment about point C, so this will be, since this 155 Newton is going to cause a couple along negative x-axis, so we will write it as minus 155 multiplied by the radius, that is 0.075, and this 240 Newton is going to cause couple along positive x-axis, and we are getting this direction by using the right hand thumb rule. So this will be plus 240 multiplied by 0.075. So, and both of these are in I cap. So this comes out to be 6.375 Newton meter I cap. Now we have replaced these four forces system by two equivalent forces at point B and C, and two equivalent couples acting at point B and C, that is MB and MC. So now we can get the value of equivalent force that is acting on system about point A, and that will be the equivalent force that is acting at point B and equivalent force that is acting at point C. So at B, the forces that we have calculated was 49.593 I cap minus 351.255 J cap plus minus 389 K cap minus 68.59 I cap. So if we collect the coefficients of I cap and J cap, J cap and K cap, it comes out to be 49.593 Newton I cap minus 419.845 J cap minus 389 Newton K cap. So this will be the equivalent force about point A. Now to calculate equivalent moment about point A, so we can get that value by, that is moment that is already acting at point B, moment that is already acting at point C, plus position vector of point B with respect to point A multiplied by the force, that is resultant force that is acting at point B, plus the position vector of C with respect to point A multiplied by the resultant force that is acting at point C. So now we can put these values, that since all of these values we have calculated, so MB will be minus 5.25 I cap, MC is 6.375 I cap, plus, now since position vector of B, we can see this diagram, B and C both are on x-axis, so we can directly use its x coordinate. This distance is given as given in the problem is 225 mm, so it's in meter, it will be 0.225, so 0.225 I cap multiplied by the force vector, that is 49.593 I cap minus 351.255 J cap, plus position vector of C with respect to A will be 0.45 I cap cross multiplied with the force vector, that is minus 389 K cap minus 68.59 J cap. So we can solve this. So if we solve this, it comes out to be 1.1 1 to 5 I cap. Now this I cross I will give 0, I cross j will give k cap, and this will be minus. So minus, if we multiply these two values, it comes out to be 79.032 k cap. Now if we solve the second here, so I cap cross k cap will give minus j cap, and 1 minus is already there, so this will be plus 0.45 multiplied by 389 will be 175.05 j cap, and if we multiply the second term here, so I cross j will give k cap, and 1 minus is there, so it will be minus 30.87 k cap. Now we can collect the coefficients of I cap, j cap and k cap. So moment about A comes out to be 1.125 I cap plus 175.05 j cap minus 109.90 k cap, and unit of these moments will be Newton meter. So this is the final answer. This is the equivalent moment that will be acting at point A, and this is the equivalent force that is acting at point A.